Welcome. Welcome to Singapore. As I announced last time, I'm all alone in the whole building today because it's a very high public holiday, which was actually yesterday, but because it fell on a Sunday, it is celebrated today. And therefore everybody has their time off. And as I also mentioned, we have no air conditioning. That means the reading here in the room is about 33.7 degrees and 90% humidity. So this is why I might sweat a little bit today. But it is also a special occasion because originally we wanted to go to Einsiedeln, to the library of Professor Oechslin. As you remember, this was not possible. So we took the opportunity to go into some things that we wanted to talk about anyway for a long time. And today is a fantastic opportunity to do that. As you can see from the screen, it is data mining and crowdsourcing. And it will be handled in a way. First, I go into the data mining issue, also give you some examples. And then Dongyeon Shin will present his work on crowdsourcing. Why is this all important? You see the sequence of these three lectures on lecture 5, 6, and 7, from theory, experiment, and simulation to finally design, modeling, and simulation. Simulation is always a very important aspect of all these lectures. And data, as we have explored in several points during the course of the lecture already, are a very important issue. Today, we look at how we can get data, how we can acquire data, how we can transform them, and how we can use them in some very innovative and novel ways. And therefore I feel very excited that we can do this lecture. I hope you have many questions while we go along and start to ask these questions right away. Remember last time we had the lecture on experiment and theory, and what was the third leg, the missing third leg that has come along in recent times? You remember what it was? Theory, experiment, and the third, what was the third? Simulation, yes. So that was the introduction of simulation last time, but of course only in a very rough way. And as I mentioned, we go into deeper description for architecture in the next one. Okay, so today, data mining. Here I work together with a new PhD student that is here. It's Wahid Mosavi. He's not here today, but with him I prepared the lecture. Then it will be architectural data mining. Here we can look at some very great work by Pürkauer, Lehmann and Mikolait, one of your previous colleagues who have done architectural data mining. And then the third one, as announced, is crowdsourcing by Dongyeon Shin, and some conclusions. Brief introduction to data mining. Data mining definition, the tasks, the typical tasks that we use them for today, and the process in action. Then a very important distinction, model-driven versus data-driven approach. This is a revisit to some of the things you heard before, and some possible application domains in architecture and urban design. So in terms of data mining, we have described, if you remember, the sequence of data to information to knowledge a while ago, and this comes again and again in our discussions here. For the data mining purpose, you have to describe them in a certain way. So every object, be it a city or a building, can be described by a set of properties, or so-called features or variables or dimensions, in a quantitative and in a qualitative manner, which we call them data sets related to that object. And these data can appear in different forms, for example, numbers that we discussed already, but also for the purpose of data mining, text, images, voice, or video are very helpful. And you see a small representation of how we could use data descriptions to depict certain properties of a piece of land, which is of course abstracted here. So we see the whole thing built up from the center of the earth, if you want, from the shale to the water table to sand and gravel to the actual surface with the buildings, the parks, but then some more abstract layers on top of it, like parcels, districts, street and land use. This should remind you very much of the lecture that Daniel Aliaga gave, because he uses the same terms and the same techniques. The definition of data mining, we have the problem definition first. In this age of information, we are collecting data from our environment continuously in every shape and form. We have a very data-rich but knowledge-poor situation. That means many sensors in buildings for monitoring temperature, humidity, electricity, consumption and so on are inhaling or producing data, but we make very little with it in terms of knowledge. I think I did mention before that in the Science City campus where you are, there are several thousand of these sensors that collect data on a continuous basis, and they're sitting in huge silos, and it's time to do something with these data. So that is what data mining is for. It's an endeavor toward analyzing or mining the collected data sets in order to extract knowledge for better performance, for example, for design or management. And this process can be called data mining. And then there's a even more interesting word called data farming. Sometimes when we generate new data sets by simulation, so you can do new data farms or new data development with this data farming. But today we stick mainly to data mining. Here is a table with the main tasks. Maybe if you just read the two descriptions here on the left. So there is two sets of descriptive tasks and there are two sets of predictive parts. You remember also from last time, I hope, the different descriptions we have for simulation, the deductive and the inductive. Here you find the related terms. Now, if you do data mining for feature extraction or selection, that example in architecture would be finding the most relevant design attributes to performance of the building. This you probably already know. The performance of the building you can measure in many different ways, but you have to find the most or extract the most relevant attributes to do this performance evaluation. And then clustering. Clustering means just you put together related sets of data. Here you could group, for example, Asian cities based on their transportation systems. That would be one possible way of grouping or clustering cities in this case. That would be descriptive data. When we have predictive, then we talk about classification and prediction. So classification, for example, selecting the best material of energy or energy system for a building based on its design, internal and external features. Or the prediction, when you really want to predict how a building will perform, then we have predicting the effect of all the design parameters on the performance of the building. So this is, I think, very important distinction, the descriptive and the predictive. On the right side, you see the algorithms that are associated with these tasks. And some of them might be known to you. We look at the end, we look at the SOM, and this is the most important one we look at. You might have heard the name expert systems before or neural networks. These are simulations of brain activities that are used in artificial intelligence or have been used in artificial intelligence in the past. Let's look at some more other data mining aspects. You can do so-called graph mining, which is quite useful in network systems like social networks and transportation networks. This is quite interesting way to look at how people move through a city And if you can follow these graphs and then do data mining on these graphs, you have graph mining. Or temporal data mining. This is necessary when you want to include the time perspectives into the data mining. So you analyze the behavior of the system in regard of time. And final, spatial data mining. This is very, very good for architecture and urban design. This is the application of data mining methods to spatial data. Spatial data mining follows along the same functions in data mining with the end objective to find patterns in geography. And of course, this is something that we learned in the past, maybe intuitively or by examples. Today, we can do spatial data mining with much higher precision and also learn, we hope, more new things from it. This picture that you see on the right side is quite interesting. I have enlarged it here. And that is an example for data mining on, for example, shipping lanes in the oceans and also road networks in the countries. So you see a complete new picture of the world, a completely new map of the world that you maybe haven't seen before, maybe you have, but from this you can see that some parts of the world are very, very empty, which is mainly the southern part around the Antarctic. But you also see that most of the other parts of the world have been covered with very, very dense networks of streets and roads. Even what used to be here the Amazon jungle before has been invaded by streets and settlements completely. So only this part here basically is left untouched. The same in the Sahara and the same in some parts of Siberia. This is interesting because it maps data which are completely unrelated, it seems, to geographic data, namely shipping lanes going from point A to B or street networks onto geographic data. And it supplements our view of the world, or explains our view of the world in a different way. Imagine you could do the same for architecture. Imagine you could do the same for a building or a city and remap what you see in architecture with the data that is hidden, but which you could extract and map onto the building or onto the city that you live in. The data mining, of course, needs a standard process. Otherwise, it's hard to compare results. And here you have one of these standard processes from the cross-industry standard process for data mining, the so-called CRISP-DM methodology. You go from data understanding and business understanding to data preparation, to modeling, to evaluation and deployment. And deployment means you deliver it to the customers. Or a different follow up on this, would be this one, the processes stretched out. So you start with data, you select certain data, you cluster them, for example, in a pre-processing procedure, then you transform them, then you do the data mining on the transformed data, you discover these patterns, and then those patterns you can evaluate, interpret, and if you're lucky, you can create knowledge out of this and give this knowledge to your customers, to your students, or to your clients as an architect. So this is the knowledge discovery in database methodology. And possible research areas using data mining in the building level or in the city level, this is really fantastic. I really like this graph that Vahid discovered, because it is something that we've been trying for many, many years, and now with a more advanced technology, it becomes more and more possible to do that. So, for example, in building energy management, you can use data mining to discover where you have the weak spots of your building. You can look at it in order to do this sustainable design in buildings and on the urban level, to reduce the greenhouse gas emission, to discover the factors that have effects on greenhouse gas, or how we can reduce them through better design. And if you're lucky, you can identify some causal variables for building energy fault detection. So you can discover real big problems. Let's zoom in on this graph here on the right. And there we have a representation of the building. This could be based on a GIS representation here. You have a new building in here. You have here the depiction, for example, of the wind data displayed in graphical form. Or you have here the energy use, the potential energy contribution by renewable energy sources in and around the building, and you have the net CO2 production of that building. More important, on this graph here, you have different pointers that show over the course of the year. You can see it starts with January, and this is not in kilowatt hours, but it's in BTU, which is the British thermal unit. You can see here how much energy, for example, is lost through windows in a conductive way through the individual months, and so on, and how much is gained through people being in the building or lighting and so on. So you get a profile. All these data are really floating around, but if you use them in a clever way, you can start to make better design with it, hopefully. So far, so good. This is more or less traditional. This you should know. Some interesting new approaches or distinct approaches that are developing in recent years are the model-driven versus the data-driven approach. And in the model-driven approach, we have a global model. We hope that it is right. We have to make simplifications, and we see that in real-world applications, it always has a lot of simplifying assumptions. Example would be, for example, what you learn in the courses, in some of the courses by Professor Leipengut, where you have these energy models, which are really model-driven approaches, for example, ecotech and these type of programs. Data-driven, if we have enough data, we can identify and analyze many relationships between those sets of variables known as system identification or structure identification and function approximation. And this is, for example, something that Dongyeon Shin will show you at the end. Let's look at an example in architecture. Here, it's a project by Pürkauer, I mentioned that before, and Anne Nicolait and Niels Lehmann, called U-City. At the beginning, there were also data. Data, huge amount of data that we had to acquire from the city of Zurich in this case. And these are just numbers, as you can see. They are earmarked in certain respects because these are the ones that are interesting for us. What can you do with this? You can take and mine these data, and of course in Zurich, in Switzerland, we hope that they are correct. And we can now link them to spatial data. If you can read German, you can see that somebody made a profile for herself or himself saying, this is the way I would like to live. For example, in terms of rents, in terms of Kinderfreundlichkeit, being good for children, in terms of traffic, in terms of public transportation, in terms of vitality of the quarter, in terms of cultural quality and access of the quarter, in terms of health, in terms of education, in terms of closeness to the sea or the river, or also in terms of green space, closeness. And then you can have the requirements of a certain person. This is the black part. Somebody says, this is and this and this and this is important for me. You make a profile of this person. And then you can see in a certain place in Zurich where you put this person, how much this profile is true or not. So this is very the collection or the boiled down result of this already. You can do that for one place. You can do that for many places or many people who have all different profiles. Different people have different ideas where and how they want to live, but it's always following the same criteria that you can see on this circle. So for many people or many people or hundreds of thousands of people actually in Zurich. And then you can overlay that with the different qualities or data parts or data descriptions of Zurich. Here you see different maps. You can see, for example, See und Flüsse, so lake and rivers, education, health, culture, vitality, public transportation, children, cribs and so on, greenery and forest, intensity or height of the rents, and traffic intensity. You can go on and take the same data and make Now weighting factors. You can say, how important is it for me to be very close to a lake and a river or not? So if I want to be less than 200 meters away from the lake, then it is very dark. And if I don't care so much, up to a kilometer away, then it's light brown. The same you can do with all the other criteria, and then start to overlap these different criteria visually. And it's amazing, you get all different representations of Zurich from that. Look at this, it always looks different. The city you thought you knew suddenly is a different city. So if you look at the closeness to lakes and rivers, you have this one here on the top left. The educational parts, you sitting right here somewhere out in Science City. Health parts, you can see very, very different parts of Zurich. But the lake and the rivers are the inverse of the greenery and forests, as you can see here. Closer to the Uetliberg or the Zurichberg, it is very black, so it's close to it. Whereas here in this area, you have further access to the forest. Now you can start to overlay all of these profiles, and you get very, very interesting new maps of Zurich. Just for the graphic quality, I like them very much already, and you can overlay them and have different parts of wishes that you express, increase the weighting for whatever river in this case, and high rent or vice versa, and you get very, very different parts. Here, focusing in on a certain profile of a user, it gets closer and closer to the so-called Beckerstraße, which makes this very attractive. Then you can turn it around and say, okay, I want now certain weighting factors which are important. I want to go shopping, I want to go close to the river, I want to have more importance on children, I want low emission from noise, I want educational facilities, I want good health access, and you give the percentages for each one of these parts that you want. And then out of this, it identifies area which are interesting for you. Then you can scale or you can zoom even more in, and you come to individual buildings almost according to your profile that you set here in these weighting factors, and brings you to the individual building. And you can go into different plots now in the city, and you can start to compare these plots in terms of your criteria. And you can see when you start adjusting your criteria here, and this is an interactive application, then they become more or less attractive. And you can see they fulfill more or less your requirements, from, in this case, 97% to 89%. So these students made a huge work, all extracting this from these data they got from the city in terms of data mining. They even visualized this, very nice, and you can see that now, how the density they visualized the attractiveness, they visualized the overlays of the different parts of the criteria that they set. So we're flying around first, and we look at the density. That's very interesting. And then you will see different colors coming up. So this relates to the different requirements that the users had for it. And then you will also find some of the areas are more attractive, or they have an over demand, and others have less demand. So you can see already in the Seefeld here, there's an over demand, where in some areas here, at least at the time they got the data for, there was under demand. And you can see how this map, three-dimensional map, two-dimensional map, now identifies clearly where you have more demand than space, or more space than demand. So I think this is very, very beautiful outcome of this data mining, and you can go deeper and deeper into their model. So if you're interested, please do contact these students. So this is an example from architecture, urban design. And now I want to switch over to Dongyeon Shin, because this was all attracted from dead data, if you want, from the past data. Dongyeon Shin will now show us how exciting it can be if you get these data and data mining from live data, from you yourself. Dongyeon, do you want to switch?
Yeah.
And while you do that, Any questions to this?
How do you keep the data updated? I mean, once you've made a huge effort and it's out of date,
Yes.
how do you keep it updated?
This is of course, this is the value of a database, if the data are updated or not. Typically, the people who do the data mining, they should not be doing the quality check on the data, because it's such a humongous work. You need to get the data from reliable sources, from many, many people, and you have to accumulate them. For example, at ETH, every year when we bring out the yearly report, we have to rely on the input of the professors that they gave us the right data to be published in. We cannot do that from the, let's say, controlling of ETH to go into each individual professorship and check it. We have to rely on the quality of the source. And that is the crux with data mining. But maybe what you see now from Dongyeon, you can, in this case, you can really do it yourself. You can really guarantee the quality of the data yourself. Okay, Dongyeon.
Okay, hello everybody. Today I will present about the crowdsourcing simulation platform. I want to ask first question with this question. Have you ever imagined or have you ever thought about the what the specific urban simulator? When I heard about the word the urban simulation, I simply imagine like this. There is a 3D model, urban model, and over there is implication models, urban behavior models. Then if we implement this kind of urban behavior activity model into the urban simulation, the 3D model, then we can see what is happening at the moment, what will happen in near futures. But I realized this is easy to imagine, but it's not easy to embody the idea because urban environment is really too complex and too dynamic. So I thought maybe we should question the next one. Then where all the complexities and dynamics come from? Then I thought that comes from human behavior, human activity. Human activity and behavior makes these kind of complexities and dynamics. So I suppose if we implement real human activity and behavior into the urban simulation platform instead of the virtual agent like this, then we can automatically implement urban complexities and urban dynamics too. Then I noticed and found that this kind of approach and behavior we call crowdsourcing. Okay, this one is one of the best examples of crowdsourcing. Wikipedia made a place to collect the people's knowledge, people's information to the central place. Then people voluntarily contribute their knowledge to the central place, Wikipedia. Then now we got one of the biggest encyclopedia in the world, like this. And what about the Facebook? Facebook is not supposed to use the crowdsourcing idea, but already 800 million are using the crowdsourcing, Facebook. Then we can guess a lot of information through their usage, through their behavior in Facebook. So they didn't suppose using crowdsourcing, but we can mining the data through the crowdsourcing idea. Then I looking for what kind of technology? How can I adjust? How can I adjust this kind of ideas to the urban simulation platform? Then I found that the smartphone has many sensors. So through the sensor, maybe we can find the possibility to collect user behavior, user behavior activity data. We already have high performance mobile device, so we can sense people activity. And there is already well-developed social network technology, so we can share, the information between the people. And there's already good wide area geospatial information system like Google Earth, so we can easily visualize the user data. Then we can build up the crowdsourcing simulation platform combining with this technology. And first I look for what kind of urban behavior we can collect through the mobile sensor. Then firstly I experiment with detecting the transportation information. We can sense the different kind of vehicle lighting activity through the mobile sensor. Then we can translate it into the CO2 emission, energy consumption, and home and working place, because we are also collecting the location data. So during the daytime, if somebody stay at the Henkelberg mainly, and at the nighttime, somebody mainly stayed at somewhere the Oerlikon, then we can easily guess his working place may be the Henkelberg, and his home place might be the Oerlikon, like this. So implementing this kind of analyzed data to the urban simulator, we can simulate the urban. We can simulate. So I made a simple application which can which can sense the acceleration. So we can log the data like this: the time, XYZ acceleration, and longitude, latitude, location data, basically. And this is very simple structure. But if once we draw the graph with that data, then we can see the many kind of information. For example, the car, bus, and walking activity has significantly different acceleration sensor levels. So I statistically arranged the different acceleration among the different cars, different vehicles. Then we can see this kind of graph. So which means we can distinguish out through what kind of vehicle you are taking through your acceleration level from the mobile phone. I want to show one example, this one. This is my acceleration, my behavior data. I took the tram and to go to the central Hauptbahnhof station of Zurich. Then I took some food at the restaurant. Then I walked to the post office to change the money. But at the post office, they don't have a Singapore dollar, so I walked to the Hauptbahnhof station again, then exchange center, I change it, then walk to the tram station, took the tram, and at the Buchheckplatz, I changed the tram to bus 69 to come here, ETH Henkelberg, and at the Henkelberg, I walked to the HIT building to come here. Then I put this data to the detecting engine which we made, and these three activities is detected as vehicle lighting activity. Then we will see what we can do actually. First we can calculate your CO2 emission. Then we will collect your data and your neighbor's data and your neighbor's data too. So basically, we can compare your data with your neighbors, with others, and with your city. So we can indicate your sustainability with many data. And here is the second version of the application. The first version of application has no user interface. So when I collect my friend's data, I should have to bring my smartphone. Then I have to instruct how to use this, and then I can give the mobile phone to my friend. Then I can collect data. But this version, I suppose, it had the very easy user interface to contributing on the market using the app market. So you can see, I'm trying to visualize your life pattern first. The size of circle shows your time duration of staying. So 52% of time, your lifetime, you're staying at home, and 18% you are staying at the working place, and maybe on the weekend you stayed at some blue circle place, and the gray circle shows your irregular visiting, like that, etc. And you can also adjust the time threshold with slide bar. And also the lifestyle analyze. You can easily guess how much time I use for leisure and home place and working. And you can also see the CO2 emission level is like this, and your sustainability. So the blue circle shows your historical changes of sustainability. So you are going to, your CO2 emission and your activity behaviors results. So you change your behavior to more sustainable life patterns. Then you currently positioned here, and you also can see the orange circle shows your neighbor's average, your city's average. So you can compare with your sustainability with others, like this. And then what we can do actually, you can find trends based on your life pattern. At the Facebook, we can make a friend who you know already. But here you can find a person who has a similar life pattern as you. Then you can ask to make a friend like this. And you also can select the option what aspect you are considering more important. So like this, the home place, you can check the working place, leisure place, and matching threshold you can adjust. So you can find the person who is the most matched as your life pattern. Yes, thank you.
We cannot hear you.
Okay, sorry.
Now we can.
Let's go back.
Yeah.
Yes, now it's okay. Now, data mining and crowdsourcing was today's point. Now, next time it's design, modeling, and simulation. Some conclusions from today. Data of reliable quality and quantity are necessary for the development of better models, simulations, and scenarios. That was your question before. They have to be reliable quality. Data mining has found applications in fields like energy, that's what we looked at, insurance, security, and many, many others. Data mining in architecture is a vast new research field which is really widely unexplored, and that could increase our knowledge about architecture and urban design, and it could thus also become an important design support technology for the future. In particular, in this field of data mining, crowdsourcing in urban data acquisition for dynamic urban information modeling will be a major source of progress for the design of future cities and the improvement of existing cities. So with this, I want to thank you very much for your attention and ask if you have any questions.
I've got a question about the model we saw before, the crowdsourcing, the last model this year.
Yes?
Isn't it a big problem that there was actually the data taken was actually soft data? So people would actually say, okay, well, I would like to live close to the water, I like to live close to the forest, but it's and it was turned into hard data. I can imagine that someone really likes to live close to the water, but if he found a really nice house on the other side of the city, he suddenly changed his mind, and then the model at the end isn't worth anything anymore.
Yes, that is a very interesting observation, which actually happens, that through using this model, actually your perception changes, because suddenly you see other things that you were not so much interested before, which suddenly override your original intention. This does happen, that's true. The only data which is fixed is the geographical data, the costs, the rents, the closeness to the services and so on, but the people's preferences, they do change based on what they see and when they start comparing. You're absolutely right. And therefore this part is interactive. So your own selection choice part is interactive, whereas the rest is fixed.
Yeah,
but this yeah.
It's still based on environment and not on. So you'll see eventually you see a block which is obviously the perfect place for you to live, and when you visit the place you think, okay, I'm not going to be happy here. It looks, for example, the building looks awful, or I don't like the people living here, or so I don't think it's the model so far is maybe there's a new opportunity with crowdsourcing, but I don't see the quality of the model shown.
Yes. This is true, except for the images that you saw at the end. They have taken, of course, pictures of the most important examples that they used, so people could look at the buildings and say this is good or not for me. But you're right, they cannot look at the neighbors. This is something that you will learn only if you move there. But actually there are applications now in Zurich, apps that are doing similar things if you have used them in Zurich. So that is finding its way into the real market by time. But the combination of crowdsourcing and the hard data, of course, would get you even closer to your perfect location where you want to be. The one case that they checked and tested was with Professor Kees Christiansen, who made his profile. He would like this. Then they looked, or he said where he lived, and it was indeed the case that his profile and the place where he was almost matched completely. So you find these cases. This of course gives you hope. But it's one application. Of course, we want to turn it around. This is important for people who want to go into real estate and these kind of things. If we want to turn it around, go into design, we have to look at different criteria, and then it becomes, I think, really, really interesting. Good. Next time, as I said, it will go more into architecture. I'll also show you some applications where it's quite dangerous, actually, to have this data, but you will see it yourself. So with this, I don't want to keep you any longer. Thank you very much, and have a wonderful afternoon. Bye-bye.
Thank you.
Bye. Thank you.